Thank you for the invitation, and I'd like to apologize because I cannot be physically present today. I'm learning Spanish, so it won't be perfect, but at least I will try. And if there's something that is not clear, just ask, okay? My name is Francisco Javier Van Hoot. I work for Fluxus as a manager of Fluxus Chile here. This is completely new for me here in Chile because we bought a share of natural gas in Quintero 6 months ago with our partner EIG from the US. But anyway, I'll introduce you to Fluxus. But I think it's a good example to understand how we see green hydrogen transportation, which is something that won't be easy. Fluxus is a company that is from Belgium of energy infrastructure. We're not active in the molecule business, of the gas molecule business. We're just using infrastructure. We have infrastructure in Europe in at least 10 countries in the northern part of Europe, in the south, and the east and west. And we've been in Latin America for 3 years already. And we have an office in Rio, in Brazil. We've purchased a share on the DBG pipeline, gas pipeline. So we have an office and some headquarters there. And here in Chile, as I mentioned before, we have purchased a share on the gas import port from GNR Quintero of LNG, sorry, Quintero. And we also have challenges to develop the company here, also with other type of molecules. And Chile is a country where we will produce large quantities of green hydrogen. And Fluxus will help contribute on this effort and help the country develop this industry and thus make the connection with the consumption market, right? In the northwestern part of Europe, where we have many infrastructures. We have three types of infrastructure: terminals to import LNG. We have five of them under operation: four in Europe, France, and Belgium, and Greece, and one here in Chile. We also have gas pipelines, 12,000 kilometers of gas pipelines under operations in Europe and in Brazil. And finally, we have a third type of gas infrastructure, which is underground gas storage in the northern part of Belgium. Our strategy in the group is a strategy that is focused on energy transition. I'm going to speak about 30-30-30 here. What you see here, 30 by 30 by 30 on the page, because Fluxus has tried or has had the ambition of transporting 30 terawatt-hour of hydrogen, 30 million tons of CO2 for by 2030. It's a clear strategy that we have. It's not something we'll do alone. We will need partners for this purpose. Fluxys is only one part of the value chain and we will transport, but we need to do this with partners. We want to expand. We want to develop to be able to transport other types of molecules like hydrogen, CO2, and safety is also very important, right? Nowadays. Surely in Europe with the crisis, with the Ukraine crisis, it's something that'll be even more important. It'll gain importance. It's very important for the future, and with the energy transition, it's also important. And it's one of the reasons why we have invested in LNG Quintero here in Chile. It's a topic that's even more important here in Chile. And LNG Quintero is an asset in our infrastructure part, which is very important for the country and will support energy transition. It's something that we've mentioned before today. In Europe, the topic of transition is a high priority in the political agenda. And for us and for Europe, not only are we talking about electricity, but we will have an electrification of many sectors. But we won't be able to electrify everything. There are procedures, industrial procedures, that will not be easy to electrify. Therefore, we will need molecules. And as we mentioned before, there's the issue of transport and of storage, which is not easy. And there's some molecules that could help here, right? Molecules. Now, Fluxus tried to help with this. During the transition, we have to consider three very important variables: sustainability, of course, affordability. Price is something that is very important. It's not easy, but in Europe we're lucky enough to have well, the coal price is very high, but with that it's not easy to develop green hydrogen projects or CO2, right? It's an effort that we need to make with politicians. It's a challenge everyone will have to develop these new energies, which will be more expensive than the energies we have now, right? Finally, we have the security of supply. I'm not going to repeat that word in Spanish, supply. The situation is easier today. Tomorrow won't be easy. We believe as Fluxus that we will have different types of infrastructures in parallel. We're lucky enough to have infrastructure today that we will use to transport other types of molecules. Today, we have CH4 with Fluxus, which is natural gas. Tomorrow, we will have the same assets, but we will be able to transport other types of molecules like hydrogen, but in addition to CO2. I'm not going to speak about CO2 that much today. And the critical role of Fluxus, the role it currently has in Europe, is to import natural gas. We are a small country, but we play a critical role throughout Europe. We have assets that are larger than what we actually need for our country, but with the crisis, it's more than yesterday, right? We transport much quantity of energy to other countries, and surely to Germany. Per day and hour, we transport an equivalent of 34 gigawatts of energy with gas per hour to Germany. That's a role that we will have to play with green hydrogen too. So we are developing gas pipelines or hydrogen pipelines. We're also creating terminals to import ammonia in the Antwerp port, for example, just to play this import role, right, in the west of Europe. It's not something we do in an isolated manner. We do it with partners throughout Europe because Europe believes much on the reconversion of gas pipelines, and each country has made their calculations to identify which gas pipelines we can use to transport hydrogen in the future. It's worth noting that the northwest part, and there's a link with transport that's great here, the northwest part, northwestern part of Europe does not have that much wind power either, or not enough wind. So we will need to import these new molecules, and it will not be, it won't be take the imports from countries, neighboring countries, but we will have imports from places that are far away, very far away. And how will we do this? It won't be easy, but I'm going to go back to this topic. We've conducted a study, partners from Belgium, other companies from Belgium, from France, to calculate the cost of production, from production to how we receive green molecules, right? Different types of molecules and throughout the world. And it's a public study and report. We can share this link with you after this presentation. But what we found is that there are some type of molecules, for example, ammonia molecules, where transport is not that expensive, transportation, right, for this type of molecules. So we could transport this or ship it to production places that are far away for consumption. It's not the case for all molecules. Methanol and ammonia could actually help, it could work with no issue. And in turn, there's some countries like Belgium and Germany, and they will need to import from countries that are far away. How will we do this? Transport of green molecules. It's not an easy topic. It depends on the distance, on the quantities we've seen, and different factors. But our vision is that for short distances, and if we have the chance to do so, we can probably create a pipeline that's upstream, like that's updated, so we can transport technology, cheaper technology, and we have an end market which is very large for green hydrogen, for example. It's not the case for ammonia, but I'll go back to this. If we talk about long distances, it's not that easy with the gas pipeline, right? That's obvious. We need to look for alternatives to make to condensate the energy in the molecule for it to be easier for shipping. We're lucky enough that there are options. There's not a unique option that's the best, that's the easiest. Of course, we have pros and cons, but yeah, we do have many options. We have liquid hydrogen, which is a molecule that is not easy. It's a molecule that's liquid at very low temperatures. It's not that easy to transport, and to transport in long distances is not easy. There's loss of energy, enormous losses of energy. Therefore, despite the fact that there's a large market for green hydrogen, it's not easy to transport it. We've heard much about green ammonia today. Why? Because it's easier to transport and to store. It's a molecule for which there's an infrastructure today, but the challenge of ammonia is that there's no large market for it now, and the technology to break the molecule, break it down, and to obtain hydrogen again is a technology that is new, that is expensive. There are other options, and that's a bit discussable, right? Methanol, which is here number 5 in my page in the slide, and it has an infrastructure. The advantage is that it has the existing infrastructure, but we also have to work with CO2, which is not easy all the time. We also have the traceability of CO2, that issue, and coal. There's coal in the molecule, which is something that we try to avoid sometimes. And I'm going to mention liquid organic carriers, but it's a concept we don't hear that much about today, so I will not go deep into liquid organic carriers. But what we've heard much about is ammonia, right? And this is a topic that I believe we must develop together, right, jointly, the technology for this end market, final market. If we have the cracking technology for this purpose to crack the molecule, it's technology we must develop. There's also technologies that could be the largest market, right? Technology for ammonia consumption. Maybe we can see turbines to see what would be the best for large markets and to aid with the to help ammonia become a green particle, right? I believe it will not be easy. I think we will see different paths that will develop in parallel to help different sectors, energy sectors, to reach decarbonization. It will not be easy, and we have to do this together. This is the end of my presentation, and thank you very much for listening.